we can look at our circuit again. Now that we have it drawn this way, I'll draw it with circuit elements like this. So just our battery and our resistor, and define a few points on the circuit and really think now carefully about what's happening to a charge carrier. So point 1, point 2, point 3, and point 4. Those are the critical parts. This battery gives us delta V bat. We know the long line is plus and the short line is minus. All we need to know. So let's imagine a positive charge carrier. And what happens to it in its life in this circuit? Let's start at 1. It's just sitting at 1, minding its own business. It's just sitting there. We define it to be at 0 volts. Just like when we were doing potential calculations, we said we'll call infinity 0 volts. You always get to call somewhere 0 volts. So we are going to say right there, we're going to call that 0 volts. When it goes from 1 to 2, the battery does work to raise it to V bat. We don't have to call it delta anymore because we've defined 0. So it went from 0 volts to V bat volts. Okay? From 2 to 3, it flows. So current, it flows. Actually, we're thinking of a single carrier. Let's not call it a current. The carrier flows with no drop in potential. It does not lose any potential energy because we think of these wires as perfect. The charge carriers just move in them. They don't dissipate any energy. They don't lose any energy. They just move. It's not really that perfect, but basically it's a lot better than the resistor. So the metal wires we think of as perfect wires, and we just think of a simple circuit. And then it goes from 3 to 4. And here we would say the carrier, it flows through the resistor and it loses a potential delta V equals what? Equals the current times the resistance. Delta V equals IR, like we calculated before. So you can apply that to this individual thing. So it does lose energy there. It goes from a high potential to a low potential. And we thought a little bit about where does that energy go? It goes into heating the resistor. And then 4, and then let's see, 3, well, and then at 4, it sits at 4, and it's back where it started. Okay? That's the cycle. Now, a lot of that was not exactly what's happening, right? Because these circuits use metal wires. They're really metallic conductors. So we say, oh, well, we have current always goes from plus to minus because that's what a positive charge carrier would do. Well, in reality, we have electrons. And electrons are negative, so they actually go the other way. So in this circuit, in reality, it's electrons flowing like this. But we think of it as current flowing like this because we think of current as positive charge carriers. Or we define it to be a positive charge carrier when in metal it's really negative. So you want to keep that difference. We've mentioned it before, but really keep that straight. Even in electronics, you got to keep that straight.